Hello everybody, my name is Mr. Yosef and today we're going to review simplifying rational expressions. Rational expressions is when you take a polynomial and you divide it by another one. And when we look at number 9, we see that we have a linear function dividing by a quadratic function. A linear function and quadratic functions are both considered polynomials. So x minus 8 stays as x minus 8. And then I need to ask myself what two numbers multiply to 72, negative 72, and add to the number 1. If you can't tell, remember there's a 1 right here. So I hope that we see that's going to be x plus 9 and x minus 8. This is not a video where I'm going to review factoring too much. So if you feel like factoring is something that you feel like you still need more help, I would definitely recommend watching my older videos on factoring. Here I'm just trying to tell you like what is our objective. Our objective is to use factoring to divide factors out to make it more simplified. So here x minus 8 divided by x minus 8 is just 1. And it's going to be really important that you include that 1 because the answer is not x plus 9. Because you're dividing both terms, the answer goes in a numerator, which is 1. And then you have an x plus 9 on the bottom. And we are officially done because there's nothing else that you can simplify here. As we move on to number 10, this is pretty similar. I'll just label this. This is my product. This is my sum. You want to think of two numbers that multiply to negative 54 and add to negative 3. You know the numbers have to be 3 apart, so they have to be pretty close to each other. So when I think about the number 54, I remember 6 times 9. And also you can you can cheat a little bit and think about the denominator because sometimes that gives you a hint of what should be up there. So if I do negative 9 times 6, that's negative 54. If I do negative 9 plus 6, that's negative 3. So I know here it's x minus 9 and x plus 6 over x minus 9. Then you're going to divide both these terms, and you're going to end up with x plus 6 over 1, which is just x plus 6. I hope that you see that when you divide by 1, it's not necessary to write in the denominator, but when you divide and you have nothing left in the numerator, you must include that 1. So this one is fine because here the x plus 6 is on top. As we move on to number 11, 11 looks strange. You just did 2 examples that look pretty similar. You're thinking 11 looks different. You just got to stay calm. You got to look at this and ask yourself, what is the biggest number that I can take away from or factor out from 56 and 72? And the answer to that is 8. I don't expect you to get it right away or to always be that quick, but it's kind of a trial and error thing. If you start with 2, you're like, okay, 2 works. 4 works. Does 6 work? No, because 6 times 9 is 54. And I just kind of proceed in that fashion. And then here I'm going to highlight 8 and 32 because 8 divided by 32 is going to be 1 over 4x because 32 is divisible by 8. And here you see that this one is not necessary because we have something in the numerator. So when you have something in the numerator, you don't need that 1. And this ends up being our final answer. Let me be consistent and use the same color. And then for this, I probably should have used this color. All right, let's keep rolling. So number 12, 2 numbers that multiply to negative 30 and add to 7. Once again, there's a lot of different ways to multiply a 30, and I need to get a 7. So what pops up to my head is 10 and 3. Because if I do 10 minus 3, that would definitely give me the 7 that I want. Now when I'm working with the bottom, this one looks different. So whenever something looks different, I'm always thinking GCF. So when I look at this problem, I see that 9 and 90 both have 9 in common, and x squared and x have 1x in common. So I'm allowed to factor out a 9x. 9x times what gives me 9x squared? That's just x. And 9x times what gives me 90x? That's just 10. And as you can see here, the x plus 10 divides that really nicely, and you end up with x minus 3 over 9x. And then I'm finished. And now we get another problem, and this looks similar to everything that we did on the top. The only thing I'm going to make sure is there a number that all of at that 3, 26, and 9 are divisible by? Unfortunately not, because 26 is only divisible by 2 and 13, and 3 or 9 are not divisible by either. So I know what this one is kind of a guess and check one. So I asked myself, how do I multiply to 3x squared? Well, it can only be 3x and x. And now I know that whenever I multiply 3x and this number, and then these two, that when I add them, it gets me 26, but the two numbers still have to multiply to -9. So what I'm thinking here is this 3 needs to multiply some number over here. And I'm thinking that it should be a bigger number because I want to get close to 26. Because to get 9, it's only 1 times 9 and 3 and 3. So let's say that I did put a 3 here and I put a 3 here. This is 9x and this is 3x. Even if I was going to mess with the signs, there's no way that a 9 and a 3 are going to give me 26. So I'm going to go back and I'm actually going to put a 9. Let me make this smaller. Sorry. Let's go ahead and put a 9 here. Because if I put a 9 here, then I'm going to get 27. And then that means this needs to be a 1. And that's 1x. And you see now if I make this positive and I make this negative, then 27x minus 1x is 26x. -1 times 9 is -9. And that checks off both boxes. So I know that this is true. And I'm going to erase this because remember, I always tell you that the hardest part about this is that factoring just becomes secondary. Because this was only part of the process. Because we still have to factor the bottom one. So now we're going to focus on this one, which is in blue. And I see that every number here is divisible by 5. So I can take a 5 out. And I'm left with x squared plus 8x minus 9. And now I have to factor this part, which will be, let's see. What two numbers multiply to -9 and add to 6? Add to 8. Well, that's going to be a +9 and a -1. And then the x plus 9's cross out. And this is what you are left with right here. Like I said, it happened pretty quickly once you start seeing everything. Let's move on to 14. So 14, once again, I'm going to look at GCF first. I always see if there's something I could take out. I can take a 2 and an x out. So I'm left with x squared plus 8x plus 12. And then on the bottom, this one could be tricky. I feel like this one gets people. You want to multiply to -6 and add to -1. So if I think about this, I'm going to make it -6 and I'm going to make it +1. Because -6 times 1 is -6. -6 plus 1 is -5. Do you see how I just made that mistake? I don't want to get -5. I want to get a -1. So 6 and 1 are wrong. I should have used 3 and I should have used 2. Because -3 times 2 is -6. -3 plus 2 is -1. So that works. And Once you think you're done, you're not, because we still got to factor this part. So that's going to be 2x, x plus 6, x plus 2. And we still got the x plus 2 and the x minus 3. And now we can cross out the x plus 2's. And we get 2x, x plus 6 over x minus 3. And let's go ahead and shade it our color. Which doesn't even shade this one our color from the past. So let's do this one on the bottom. So this one, I'm going to factor out of 5x. And I'm going to left with x minus 1. And you're probably thinking on this bottom part, there's nothing that you can do. But I hope you notice something particular about this one. I don't like my x being negative, and I don't like that it's written backwards. So if I was going to rewrite this, it's technically negative x plus 1. And you see that I can technically take a negative 1 out, and it becomes x minus 1. So I want us to look at this closely again. I had 1 minus x, and I decided to first rewrite it as negative x plus 1. And then I factored out the negative 1, because now what I can do is I can come here and I can put negative 1, parentheses, x minus 1, get the x minus 1's to cross out, and then 5x divided by negative 1 is just negative 5x, and our final answer ends up being negative 5x. Of course, I've had a lot of experience with this, so whenever I see that, I knew to take the negative 1 out, and I could do that. But I can see that if you haven't had a lot of experience, that you probably wouldn't think to do this. But I thought this was a pretty neat problem. Let's take care of this last one. So if you remember anything from the first semester, whenever we had 4 terms, we always wanted to try factor by grouping. So I'm going to go ahead and I'm going to try that. I know it doesn't look like it'll work for this, but that's what we were taught. When we see 4 terms, put them in parentheses. Let's focus on the first one. We're going to take out an x, and you're left with y plus 3, because x times y is xy, and x times 3 is 3x. Then we're going to look at our next one, which is negative 2y minus 6. So we're going to take out a negative 2. Negative 2 times y gives me negative 2y. Well, that's just a y. And negative 2 times y gives me negative 6. Well, that's just plus 3. We see that these are both the same. And when both of them are the same, we know that we can take our outside terms. We're going to put them in one parentheses. And then we're able to factor out our remaining term that doubled. So these two, you copy one of them down. And that's what we have. And then I'm going to divide this by, well, I need to do this part now. So if I learn anything from the last problem, this should be x minus 2 and then x plus 3, because 3 minus 2 is 1, and negative 2 times 3 is negative 6. These two cross out, and you're left with y plus 3 over x plus 3, and that is your final answer. I really like this problem because it just makes you think outside the box and just makes you reevaluate all our techniques that we learned. I hope that helps you. That's the first test, which is called simplifying rationals.